Hello everyone. Today again I'm here with another session where I'll be discussing problems based on polynomial. In our last session we have discussed about the polynomial concepts where we discussed that the basics of polynomial. We also talked about that relationship between zeros and the coefficients of polynomial. Then we saw that how we can frame a polynomial when its zeros are given. Now we have also seen some of the question in our last session. I thought to make one more session on it as there are still some questions which needs to be discussed and which is based on application of zeros of the polynomial. So let's start with the topic. So here the first question which I am going to discuss here is that find the value of k such that the polynomial x square minus k plus 6 times x plus 2 into 2k minus 1 has sum of its zeros equals to half their product. So to solve it, we'll let the zeros of polynomial be alpha and beta. So from this, what it is given is, here it is given that sum of its zeros is equal to half of their product, and we have a polynomial. Here we'll take p of x equals to x square minus k plus 6 times x plus 2 into 2k minus 1. According to the question, we can write that sum of zeros is equal to half into product of zeros. So sum of zeros, in this case it will be minus b by a, so which we can write is equals to half into product of the zeros, that will be c upon a. Here we can cancel a and a, so we'll get minus 2b equals to c. On substituting the values of the coefficients, we'll get minus 2 into, it will be negative of k plus 6 equals to 2 into 2k minus 1, which will be equals to 2k plus 12 equals to 4k minus 2. On solving, we'll get it as 4k minus 2k will be equals to 12 plus 2, which will be equals to 2k equals to 14, and so the value of k will be equals to 7. Moving to the next question, where it is given that if alpha and beta are zeros of the polynomial p of x equals to x square plus x minus 1, then find the value of 1 by alpha plus 1 by beta. So in such questions, as it is given p of x equals to x square plus x minus 1 and alpha and beta are the zeros of it, we'll find out the sum of the zeros, which is minus b upon a, that will be minus 1 upon 1, which is minus 1, and the product of the zeros, it will be c upon a, that is minus 1 upon 1, again it is minus 1. Now we have to find the value of 1 by alpha plus 1 by beta. On LCM, it will be alpha beta. This will become beta plus alpha, which we can write it as the value of alpha plus beta is minus 1, and the value of alpha into beta is also minus 1. The value will become 1. Next, see some more question based on it. So we'll get if alpha and beta are the zeros of the polynomials p of x equals to x square plus x minus 1, then find the value of alpha by beta plus beta upon alpha. So again in this case the polynomial p of x is given as x square plus x minus 1, and here the value of alpha plus beta will become minus b by a, which is minus 1 upon 1 minus 1, and alpha into beta is c by a, which is minus 1 upon 1, again it is minus 1. Now we have to find alpha upon beta plus beta upon alpha. Take LCM, it will be alpha beta. This will become alpha square plus beta square. Now, as we know that alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. So, from here, alpha square plus beta square can be written as alpha plus beta whole square minus 2 times alpha beta. So, on using that, we can write alpha plus beta whole square minus 2 alpha beta upon alpha beta. Now we can substitute the values of alpha plus beta and alpha into beta. We'll get minus 1 square minus 2 into minus 1 upon minus 1, which will give 1 plus 2 upon minus 1, that will be equals to minus 3. Let's see some more question of these type. So here the question is, if alpha and beta are the zeros of a polynomial p of x equals to x square plus x minus 1, then find the value of 1 upon alpha square plus 1 upon beta square. So to solve it again, we'll take p of x equals to x square plus x minus 1, and here alpha plus beta, it will be equals to again minus b upon a, which will be minus 1, and alpha into beta, which is c upon a, that also will be minus 1 on substituting the coefficients. Now we have to find the value of 1 upon alpha square plus 1 upon beta square. Here the LCM will be alpha square beta square, and this will become beta square plus alpha square. We can write alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta. As we know that alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. It will be divided by alpha beta whole square. When you substitute the value, you will get alpha plus beta minus 1 square minus 2 into minus 1 divided by minus 1 square, which will be 1 plus 2 upon 1, which will be 3. The next question is, if alpha and beta are the zeros of a polynomial p of x equals to x square plus x minus 1, then find the value of alpha upon beta square plus beta upon alpha square. So again, we'll take p of x equals to x square plus x minus 1. Here the value of alpha plus beta, which will be minus b upon a, that is minus 1 here, and alpha into beta is c by a, which will also be minus 1. Now we have to find the value of alpha upon beta square plus beta upon alpha square. When we take LCM, it will be alpha square beta square, and the numerator part, it will become alpha cube plus beta cube. Now we know the identity, that is a cube plus b cube can be written as a plus b whole cube minus 3ab into a plus b. So using that identity on alpha cube plus beta cube, we can write alpha plus beta whole cube minus 3 alpha beta into alpha plus beta, which will be divided by alpha beta whole square. Now on substituting the value of alpha plus beta and alpha into beta, we will get minus 1 whole cube minus 3 into minus 1 into minus 1 divided by minus 1 whole square, which will be minus 1 minus 3 divided by 1, which will be minus 4. And this is how we can solve these type of question, where we'll be knowing about either the zeros or sum of the zeros and the product of the zeros, and they will be giving some expression whose value we have to find. The next question is, if alpha and beta are zeros of a polynomial x minus p into x minus q minus r, then find the polynomial whose zeros are p and q. So in this case, let p of x is x minus p into x minus q minus r, which can be written as x square minus p plus q times x plus pq minus r. Now we have to find out the polynomial whose zeros are p and q. And for this particular polynomial, the zeros are alpha and beta. So what we can write therefore, that is alpha plus beta, which is sum of the zeros, it will be minus b upon a. That will be equals to p plus q, and alpha into beta, which will be c upon a, that will be pq minus r. Now we have to find out the polynomial whose zeros are p and q. So the required polynomial is k into x square minus sum of zeros times x plus product of zeros. Now it can be written as k into x square minus sum of the zeros. So here the sum of the zeros will be equals to alpha plus beta times x plus the product of the zeros. It will be equals to pq, which is equals to alpha beta plus r, which will become k into x minus alpha into x minus beta plus r. And this is how we can obtain the required polynomial. Next, if the squared difference of the zeros of the quadratic polynomial p of x equals to x square plus px plus 13 is equal to 144, find the value of p. So again, in this case the polynomial is given. So let's find out the sum of the zeros and product of the zeros first. So let alpha and beta be zeros of p of x. Here p of x is x square plus p of x plus 13. Therefore alpha plus beta will be minus b upon a, which is minus p upon 1 is minus p, and alpha into beta will be c upon a, which is 13 upon 1, it is 13. Now according to the question, if you see, they have given the squared difference of zeros. That means alpha minus beta whole square is given 144. And now as we know that alpha minus beta whole square, we can write it as alpha square plus beta square minus 2 alpha beta, which also can be written as alpha square plus beta square plus 2 alpha beta minus 4 alpha beta. And further it can be written as alpha plus beta whole square minus 4 alpha beta. So using that expression, we can write it as alpha plus beta whole square minus 4 alpha beta equals to 144. And so alpha plus beta value is minus p, we can substitute here, minus 4 into alpha beta value is 13 equals to 144. Now this will be p square minus 52 equals to 144, where p square can be written as 144 plus 52, which is 196. And so therefore the value of p will be plus minus square root of 196. So the value of p will be plus minus 14. And this is how we can solve this particular question. The next question is the quadratic polynomial whose zeros are reciprocal of the zeros of the quadratic polynomial p of x equals to ax square plus bx plus c, where a is not equal to 0 and c is also not equal to 0. So you have to find out the quadratic polynomial. So again start with the given polynomial p of x is equals to ax square plus bx plus c. In this case, let alpha and beta be zeros of p of x. Therefore we can write alpha plus beta as minus b upon a and alpha into beta as c upon a. Now we have to find out the polynomial whose zeros are reciprocal of zeros of this polynomial. So zeros of required polynomial are 1 by alpha and 1 by beta. So from here, the sum of zeros will be equals to 1 by alpha plus 1 by beta, which will be alpha beta. Here this will be beta plus alpha, which we can write it as minus b by a upon c by a. On solving, we'll get it as minus b upon c. And the product of zeros will be equals to 1 upon alpha into 1 upon beta, which will be 1 upon alpha beta, which will be 1 upon c upon a, that can be written as a upon c. And so, therefore, required polynomial is k into x square minus sum of zeros times x plus product of zeros. That will be equals to k into x square minus of minus b upon cx plus a upon c. On solving, we'll get the value of it as k upon c into x square. On solving, we'll get k upon c into cx square plus bx plus a, and that will be the required polynomial. Now, some of the points which we need to remember while solving some of the questions of polynomial which is based on the zeros of the polynomial. Well, the first point is that if zeros are equal in magnitude and opposite in sign, then the coefficient of x will be equals to 0, because in that case the value of alpha plus beta will be 0, which implies minus b upon a will be 0, and so b value will be equals to 0. Remember, we are talking about the polynomial ax square plus bx plus c. Second point, if zeros are reciprocal of each other, then constant term will be equals to coefficient of x square. That is, in that case, alpha into beta will be c upon a. As zeros are reciprocal of one another, we can say alpha into beta is 1, which is equals to c upon a, and so we'll get the value of c equals to a. Another point which we need to remember, that if a plus b plus c equals to 0, that is, sum of the coefficients is equal to 0, then the zeros of the polynomial p of x are 1 and c upon a. So these are few points which we need to remember and based on which the question can come. So this is all for this particular session. Thank you. Take care, everyone.